So what I want to do in this video is go through the concept of random variables. So random variables are fundamental to any sort of actuarial, probabilistic, and statistical analysis. Whatever field of actuaries or statistic you're pursuing, whether that be life insurance, analytics, general insurance, and so on, any sort of analysis that has to do with statistics or probabilities, you would need random variables. So what is a random variable? So a random variable is a function, and this function basically assigns numbers to a set of possible outcomes. In a random process. Um, let's go through an example. So let's say we have a random process. Let's say we're flipping a coin. So we have a coin flip, and the coin can have two particular values. It could either have outcomes. It could either have heads, or it could have tails. Now let's say we define a random variable x that equals 1 if we get heads and 0 if we get tails. So we can see that x is a random variable because we have a random process, so that in our case is the coin flip, and the random variable x is basically assigning numbers, which are 1 and 0, to the possible outcomes of this random process, which are heads and tails. So this is a typical way of assigning random variables. We usually assign them 1 and 0 for convenience, but um, x would also be a random variable if it were defined, such as, for example, let's say x was 8026 if we got heads, and 2025 if we got tails. And this would still be a random variable because we are assigning numbers to our possible outcomes in a random process. So I just want to bring to your attention that this is different from some of the deterministic variables that we're exposed to in high school and early on in uni. So for example, if we have x plus 6 is equal to 25, then we know for certain that x would be equal to 19. And this is different from a random variable. So for deterministic variables, I've used a lowercase letter x, and for random variables, I've used a uppercase letter x. So with deterministic variables, we can say that with certainty that x is equal to 19 if this statement is true. Whereas with the random variable x, we don't know what the value of x will be until we do the coin flip. So with deterministic variables, there is no random process. So obviously, the next question that you might ask is, why are random variables important? So why are random variables important? And I believe that it comes down to easy notation and convenience. So it's all about the convenience and easy notation. So let me give you an example. So let's say that you were doing your analysis on Chris Pratt, and we want to figure out the probability. We want to look at the probability that Chris Pratt lives for 65 more years. Let's say we're looking at something like this, And so from a mathematical notation, if you know remember from high school, we could write this as the probability that Chris Pratt lives for 65 years. And and you would have to write this whole sentence every time you're referring to this specific probability. And imagine having to write that 10 or 15 times, or maybe even 4 or 5 times alone, every time you were calculating this specific probability. So now imagine, I think what would be better if we could just define a random variable y. So let me just rewrite that. Let's say we define a random variable y which equals to the future number of years that Chris Pratt lives. And I think that and y is a random variable because we are assigning numbers to an uncertain outcome, which is the future lifetime of Chris Pratt. So x is a random variable. And now we can write this same probability as the probability that y is equal to 65. And I feel that that's a lot more elegant and convenient to write out if you want to do that repeatedly. So in a future video, we'll look at random variables more closely, and we'll distinguish between discrete and continuous random variables.